I am Leland Madhusankar. I am going to talk about point-to-point protocol Daemon remote control execution vulnerability. The content of this presentation is what is the point-to-point protocol Daemon remote execution vulnerability, remote control execution vulnerability, how it was found, how it works, how to exploit it. What is the point-to-point protocol Daemon RCE vulnerability? The point-to-point protocol PPP is a full duplex protocol that allows simple data to encapsulated and distributed through layer 2 or data link infrastructure spanning from dial-up connectivity through DSL broadband to virtual private networks, incorporating SSL encryption. As these protocols do not allow point-to-point communication, PPP is also used to enforce IP and TCP over two directly connected nodes. pppd is a daemon used on Unix-like operating system to manage the establishment of PPP sessions and the termination of sessions between two nodes. PPP is the protocol used to create internet connections over dial-up modems, DSL connections, and several other forms of point-to-peer connections via virtual private networks, such as peer-to-point tunneling protocol. The PPPD program can also authenticate a peer connecting to the network and or provide the peer with authentication details utilizing various authentication protocols like EAP. Due to the flaw in the point-to-point protocol daemon, PPPD handling of the extensible authentication protocol EAP packet, an unauthenticated remote attacker may cause a stack buffer overflow, which may allow arbitrary execution of code on the target system. This weakness is triggered by a mistake in validating the input size before copying the data supply to the memory, provided that the validity of the data size is wrong. Random data may be copied into memory, which can trigger file leakage, contributing to unintended code execution. How it was found. Discovered by IO Active Protection Research, Ilja van Spunden. The crucial problem is a stack buffer overflow flow that occurs due to logical error in the extensible authentication protocol module parser of PPPD applications, and enhancement that offers support for additional authentication methods in PPP connections. The weakness monitored as CVE 2020-8597 with CVSS score 9.8 can be abused by unauthorized attackers to remotely execute arbitrary code on affected device and gain complete control of them. This weakness is attributed to an mistake in validating the size of the input before transferring the data to memory. Because data size validation is wrong, random data can be copied to memory and can trigger database fragmentation, likely contributing to the execution of unauthorized code. The vulnerability is found in the logic of the EAP parsing code, especially in EAP request and EAP response functions in EAP.c, which are called by the network input handler. It is wrong to conclude that PPPD is not insecure secure if EAP is not allowed or if EAP has not been initiated by a remote peer using a password or passphrase. This is because an unauthenticated intruder may always be able to submit an unsolicited EAP packet to introduce buffer overflow. The vulnerable has been identified in the point-to-point protocol Daemon or PPPD. PPP is a layer 2 protocol used to establish connection over dial-up modems, DSL connection, many other physical networks, including mobile networks. PPP has been included in and expanded to include additional protocols such as the point-to-point tunneling protocol, PPTP, that is used in virtual private networks to provide encrypted connections. Throughout this situation, SEE CERT collaboration team partnered with protection analyst Ilja Van Sprundel, IOActive, who found this flaw, and software developer Paul Macarius, OZ Labs, who managed the source code to easily examine the issue and find a workaround. The issue involved a buffer overflow in the PPPD source code owing to basic buffer overflow in the Boolean expression and the implementation of conditional statements that resulted. How it works. The weakness lies in the EAP passing code logic explicitly in the EAP request and EAP response functions EAP.c that a network input handler calls. These functions using the first byte as a type take a pointer and length as an input. If the form is EAPTMD5chap4, then it looks at an embedded area 1 byte length. The rationale in this code is intended to make sure embedded duration is less than the total length of the packet. Following this verification, it tries to copy the provided data hostname, which is located in a local stack buffer after the embedded length field. This boundary check is incorrect and allows memory copying to occur with an arbitrary data length. An additional logical error caused the EAP input function not to test whether EAP has been resolved during the line control protocol process. This allows an unauthenticated attacker to send EAP packet even if PPP refused to negotiate authentication due to lack of support for EAP or due to a non-compliance with an agreed pre-shared passphrase in the LCP stage. In EAP input, the insecure PPPD code must still process the EAP packet and cause the stack buffer overflow. This unverified, unknown size data can be used to compromise goal device memory. The PPPD also runs with high privileges system or root and operates with kernel drivers in tandem. The PPPD program is also used with LWIP, Lightweight IP project, to provide PPPD capabilities with tiny computers. The default IWIP installation and installations are not susceptible to this buffer overload. However, if use the IWIP source code and modified it explicitly to allow EAP at compile time, the program can be susceptible to buffer overflow. CVE-2020-8597 is a buffer overflow bug in PPPD owing to a conceptual defect in the extensible authentication protocol packet processor. An unauthorized remote attacker who sends a specially crafted EAP packet to a vulnerable PPP client or server may cause a denial of service condition or an arbitrary code execution. As PPPD operates in tandem with kernel drivers and also has high privileges such as device or even core, any code execution may also be performed with same privileges. Through submitting an unsolicited EAP packet to a vulnerable PPP client or server, an unauthorized remote intruder can trigger memory corruption in the PPPD mechanism, which may require arbitrary code execution. According to the researchers, point-to-point protocol Daemon version 2.42 to 2.4.8 version, two versions published in the last 7 years, are susceptible to this new remote code execution bug. Many of the commonly used successful Linux distributions mentioned below have already been reported impacted, and several other projects are most likely affected as well. Debian, Ubuntu, SUSE Linux, Fedora, NetBSD, Red Hat Enterprise Linux. In addition, the number of the susceptible applications and devices, some of which are mentioned below, that ship BPD apps is also likely to be vast, providing a broad attack surface for hackers. Cisco Call Manager, TP-Link products, OpenWRT Embedded OS, Synology products. Due to a flaw in the extensible authentication protocol, packet processing in the point-to-point protocol Daemon, an unauthenticated remote attacker may be able to cause a stack buffer overflow, which may allow arbitrary code execution on the target system. This vulnerability is due to an error in validating size of the input before copying the supplied data into memory, as the validation of the data size is incorrect. Arbitrary data can be copied into memory and cause memory corruption, possibly leading to execution of unwanted code. How to exploit it? The critical issue is a stack buffer overflow vulnerability that exists due to a logical error in the extensible authentication protocol called packet parser of the PPPD software, an extension that provides support for additional authentication methods in PPP connections. For this, all an attacker needs to do to send an unsolicited malformed EAP packet to a vulnerable PPP client or server over direct serial link ISDN, Ethernet, SSH, socket-cat, PPTP, GPRS or ATM networks. Additionally, since PPPD often runs with high privileges and works in conjunction with kernel drivers, the flaw could allow attackers to potentially execute malicious code with the system or root level privileges. Remote code execution method used to exploit the vulnerable client. Remote code execution relates to the capacity of a cyber intruder to enter and make modification to a device controlled by someone without permission and unaware of the machine is situated. RCE allows an attacker to take over a computer or server by running arbitrary malware software. I use two virtual machines to test on the same computer, one as server and one as client. To connect virtual machine, I install SSH. Using the IP address, I connect Fedora 25 virtual machine as the server side and Kali Linux virtual machine as the vulnerable client. As per the instruction, I set up a pppoe server. After open the debug mode and set log file and add the log file, then I set up a pppoe client vulnerable client. Finally, using Python code can exploit the vulnerable client. Also, by sending an unsolicited EAP packet to vulnerable PPE client, remote attacker could cause memory corruption in the PPD process. I refer this repository in Github to do the exploitation. To set up a pppoe server, you can use this site. This is the Python code that I use to exploit this vulnerable. This is the look after the exploitation. And there is another code that I didn't try. I put all reference link in the description. This is the end of the point-to-point protocol Daemon vulnerability video. Thanks for watching.